So in this video, we're going to talk about alternative ways to generate vectors within MATLAB. So the way that we talked about in the first video was to actually manually enter each of the elements. And if you think about it, not only is that not going to be very efficient, but in addition, oftentimes in engineering, we're going to want to define vectors that have certain kind of periodic properties. For example, we could want to define a vector that has a fixed start point and a fixed end point, and then has elements that are spaced evenly in between, and we want to actually specify the step size. And if we want to do that, the way that we would actually do it is using the colon operator. So if you want to learn more about the colon operator, you can actually pull up the help page on MATLAB here. Usually this stuff is most easily found by actually just using Google, of course. But here you can see an example of the syntax. You can define a variable x, and you can assign that variable the value of j colon k. And if you read what that does, it's going to create a unit space vector with x elements between j and j plus m. So what does a unit space vector mean? Well, oftentimes when you're doing these sorts of things, it's just easier. Remember, the nice thing about software is free. You can always clear your workspace with clear all, to just pick a variable and assign it a value using the colon operator and see what it does. So if you look at the actual syntax here, what I have to do is just pick a value of j and k. And it says if j and k are both integers, then they're simply going to be separated by 1. So let's start with a case where they're both integers. What about 3 colon 7? If you look at what it created, 3 is my starting point, 7 is my terminating point, and then it created a vector where each of the elements are spaced by 1. So if you notice in that syntax, it said if the first 2 elements are integers. So what if they're not integers? What if I want to do it from 4 to 9.5, for example? If you notice in that case, they're still going to be spaced by 1. However, when think about the way that the software is working here, it takes your starting value, 4.2, it increments and adds 1, takes you to 5.2. It increments and adds 1, takes you to 6.2, 7.2, 8.2, 9.2. And then why doesn't it do 10.2? Well, if you think about 10.2, it's going to exceed the upper bound of your actual terminal value in your colon notation here. So that's how you can define vectors where you actually specify the start and the stop value, and you want to also specify the spacing in between. So for example, if I defined instead of x going from 3 to 7 with unit spacing, if I wanted that spacing to be 0.5, all that I need to do is add an additional value between the 2 colon elements, the start and the stop element, and this is actually known as the step. So when you think about the way that the colon operator works, what you're really specifying is start, step, stop. However, if you don't specify the step, it by default will take on a value of 1. And that is the case in when we use a lot of these built-in functions, which is actually what the colon operator is. Oftentimes, you don't have to specify all of the particular inputs, and if you don't, they will default to a specific value. So in the case of the colon operator, if you don't specify the step, it will default to 1. However, if you specify the step to be like 0.5, notice in that case you will get steps of 0.5, as you would expect. So the length of this vector, or the amount of elements, is of course going to be longer. And one of the interesting things here, and we're going to talk about this a little bit later on when we kind of define MATLAB as a programming language, is even though like this first variable that I defined x, each of the elements are integers, and x2, at least a subset of the elements are floating point numbers. In both cases, if we look at the class or the data type of the individual elements in the vector, they are doubles. And if you read that IEEE standard that we looked at earlier that defined double precision floating point numbers, you'll note that it's not for integers. There is a data type reserved for actual integers. So what's happening here is we're using all 64 bits to define a double for each of those elements of the vector. And that's using way, way too much space in order to store a very small amount of information. We don't need all those bits because when we're storing integers, there's not as large a number of combinations as to the 64. So that's just something to keep in mind that we'll be looking on later on in the course. But the key learning element that I wanted you to get from this is what the actual colon operator does. So you can you can create a vector, and you can specify its start point, its step, and its stop point. So what you want to do here is to try to use the colon operator in order to define this vector. So look at the start point, look at the stop point, and then ask yourself, what is the step in between? And what I'd like you to do to insert here is an actual screenshot showing me your code. So actually what values you use for the start, stop, and step, along with the actual output of your vector to verify that that is correct. It'll just let me grade it easier. I can obviously tell from the syntax of your code whether or not it's correct, but it's good to see the screenshot on this. What I'd like you to do next, one of the themes we're going to have a lot throughout this course, is that the best coders are those individuals that can expand beyond the syntax that they already know, actually go out and find resources that describe functions or just different techniques in a programming language and use those resources in order to generate necessary code. So the colon operator is very good if you want to programmatically define a vector with a start point, a stop point, and a fixed step. However, what if you wanted to define a vector that's pretty similar? So you want to specify the start point and the stop point, but rather you want to define the total number of values in the vector, not the step. The function that you want to use for that is called linspace. So what I'd like you to do is actually use the internet in order to identify the help file, and that's what we've been pulling up in each of these cases for MATLAB, for that particular function, and show me the code that you would need in order to generate an array that starts at 1, terminates 100, and has 30 evenly spaced elements within it. So I'd like a screenshot of your code here, but feel free to terminate it with a semicolon. Don't terminate this one with a semicolon. I'd actually like to see your values just to make it easier to grade. However, what you're going to have in 12, try it one time and don't use a semicolon. And the output will be very, very large because you're going to be generating an array with 30 elements. And we're going to look at all of the syntax again a little bit later on. I just want you to be aware that there are multiple ways to define vectors in MATLAB. You can manually key in each of the elements and specify the delimiter in order to generate row vectors or column vectors, or you can use a lot of predefined functions in order to generate either evenly spaced vectors using the colon operator or vectors with a specified number of elements using the actual linspace function.